The introduction of a new satellite-free navigation system by Russia is a significant technological development, particularly in the context of contemporary aerial warfare, where the ability to withstand electronic warfare, EW, and satellite denial is becoming more critical. The system is an advanced iteration of the Doppler speed and drift angle measuring device, S, and was developed by the Rusel holding company under Rostec State Corporation. In regions with unreliable satellite coverage or where signals are actively disrupted by EW measures, this innovation is intended to provide precise navigation for aircraft, helicopters, and drones. Interestingly, the company's press release included an image of the Russian fifth-generation fighter Su-57. The new device boasts several noteworthy enhancements, including increased durability, superior measurement accuracy, a four-fold reduction in energy consumption, and a 90% reduction in weight in comparison to its predecessors. These enhancements render it particularly well-suited for installation on a diverse range of platforms, such as next-generation fighter aircraft and unmanned aerial vehicles. The system's main advantage is its independence from satellite navigation, which guarantees uninterrupted operation in hostile environments or remote regions such as the Arctic, where GPS or GLONASS signals may be obstructed, spoofed, or otherwise compromised. In 2020, Rusel initiated work on this upgraded DSES, which was prompted by a government subsidy in 2021 that expedited research and development. The system has successfully completed all flight tests and is now prepared for serial production. It is crucial to note that the software is completely Russian-made and fully compatible with existing onboard avionics. Additionally, all key components are produced domestically, thereby ensuring technological sovereignty and resilience against supply chain disruptions. Without requiring external signals, the system is capable of autonomously measuring an aircraft's ground speed and drift angle through the use of Doppler radar technology. These parameters are essential for precise navigation. This renders the device a reliable alternative for traditional inertial or satellite-based navigation systems, providing a layer of redundancy that is essential in contested airspaces. Rostec's decision to accompany the announcement with an image of the Su-57 fighter and a radar system is highly symbolic and strategic. The Su-57 is the most advanced stealth multi-role fighter in Russia, boasting advanced avionics, integrated electronic warfare systems, and the N-036 Byelka active electronically scanned array radar. This radar offers 360-degree situational awareness and is highly resistant to interference. Rostec is conveying that this technology is not only intended for legacy platforms, but is also compatible with cutting-edge fifth-generation aircraft by linking the new navigation device to the Su-57. The Su-57 already uses sophisticated navigation systems, including the BINS SP2M inertial navigation system, which can be integrated with GLONASS, but also functions independently. The Su-57's survivability and mission effectiveness would be further enhanced by the integration of the new Doppler-based navigation system, which would enable it to operate in GPS-denied or fiercely contested environments. Additionally, the synergy between situational awareness systems and advanced navigation systems is emphasized by the inclusion of a radar image in Rostec's announcement. The capacity to detect hazards in a contested electromagnetic environment and navigate accurately without external dependencies is indispensable for modern air combat. The new navigation device, in conjunction with the Su-57's advanced radar and electronic warfare systems, provides a comprehensive solution for preserving operational capability in the presence of sophisticated EW threats. So how does this compare with such projects worldwide? Many countries are actively developing or deploying alternative navigation technologies that do not rely on satellites, as they recognize the vulnerabilities of satellite-based navigation, such as GPS, GLONASS, Beidou, and Galileo, to electronic warfare tactics like interference and spoofing. Several Western and Asian nations have prioritized the research and deployment of satellite-independent, resilient navigation systems, particularly for military and critical infrastructure requirements. The use of high-precision inertial navigation systems, INS, is the most popular alternative. Based on accelerometers and gyroscopes, these systems offer autonomous, reliable navigation that is not reliant on any external signals. Consequently, they are resistant to intrusions, spoofing, and jamming. To guarantee operational continuity in GPS-denied environments, INS technology is extensively implemented in military vehicles, submarines, missiles, and special forces equipment. Terrestrial networks and low-orbit satellite constellations are also being developed by companies in the United States, including TrustPoint Inc. and Zona Space Systems, to offer resilient positioning, navigation, and timing (PNT) solutions. These systems are intended to mitigate dependence on conventional GPS and provide dependable alternatives in urban or contested settings where satellite signals may be compromised. In addition, research on magnetic navigation, MagNav, which employs the Earth's magnetic field for navigation, indicates potential as a passive, unjammable, and spoof-resistant solution. However, technical obstacles must be overcome before MagNav can be extensively implemented. European defense companies, including Thales, have created layered navigation solutions that safeguard against electronic warfare attacks by integrating high-precision INS, encrypted military GPS receivers, and anti-jamming antennas. For naval and other military platforms, these integrated systems guarantee mission continuity and security, even in the presence of persistent electronic attacks. The current trend is toward a multi-layered approach that integrates satellite navigation with terrestrial, inertial, and other alternative systems to enhance resilience and mitigate single-point vulnerabilities. In conclusion, the new satellite-free navigation system is an important breakthrough in Russian aerospace, as it offers a self-sufficient, durable substitute for satellite navigation. Its relevance to the most advanced Russian combat aircraft is underscored by its association with the Su-57 in Rostec's communications, which reinforces Russia's emphasis on technological independence and survivability in modern warfare. Now, do you think Russia will put this technology to practical use, or is it just a technology demonstrator? Let us know in the comments. Please feel free to like, share, and subscribe to our channel.